information track again. Hope you enjoyed your coffee break. We've still got some amazing content ready for you, so let's jump right in. Our next presentation will be led by Wan Lee Zhu. He is Managing Director, Venture Capital at Suffolk Technologies. His session is titled Future of Construction, How Data and Automation Will Drive Productivity and Sustainability. Please join me in welcoming him to our stage.
I'm Wan Lee Zhu, and I'm with Suffolk Technologies. We are a built environment-focused venture capital firm. Some of you may know our sister company, Suffolk. Suffolk is a large technology-forward builder that does over $5 billion of construction across the U.S. in a number of different asset types. We created Suffolk Technologies in 2019 to partner and support early-stage entrepreneurs that are working on solutions for construction and real estate industries, and help these entrepreneurs and nascent companies navigate the complex industry structure and bring new solutions to the market. So today I'd like to share a couple of construction technology trends that we've been seeing, give you a few live examples and some videos to show you. And hopefully by the end of this session, you'll get a glimpse into what the future of construction looks like, okay? This shouldn't be a surprise to anybody here. Construction as an industry has been broken for a while. A lot of the problems in construction stems from skilled labor shortage. Labor productivity overall in construction over the past few decades have been either stagnant or declining, depending on what study you look at, relative to other sectors like manufacturing and agriculture. Over the past decade specifically, construction labor growth has really lagged construction spending. And on top of all of that, the workforce has been aging as well, which is adding to an already tight labor market. As of 2022, some of the stats show that the construction industry is actually short of over 600,000 skilled workers. 600,000, that problem is getting worse. That shortage is getting more severe. The net effect of that is that it contributes to construction costs rising faster than rent, for example. So that's one manifestation of that problem. Construction costs have been rising at a 9.3% CAGR between 2019 and 2022. Rent, on the other hand, has been rising at about a 5% CAGR during the same period. So construction costs are rising almost twice as quickly as rent. And as a result, that's putting a lot of pressure on developers and real estate investors. Fortunately, there are a couple of technology catalysts and tailwinds that can help address these problems. First, there's been significant progress in sort of first-generation system of record and connectivity companies, right? We all know Procore and Autodesk and so forth. What that's done is it's digitized some foundational information upon which we can now create analytics, machine learning applications, new user interfaces, and workflow applications. The second related trend to that is there's been a real technology leap in the form factor of computing itself. We've kind of went from desktop to laptop to mobile, but guess what? Mobile devices were also kind of high friction to use on a job site, right? Try to use an iPad when it's raining. And so what the last few years we've seen in terms of technology conversion, cloud computing, 5G connectivity on a job site, passive sensing, machine vision applied to conventional GoPro cameras, for example, have enabled a different type of computing that has a better form factor fit with the usage dynamics and the behaviors and the preferences and the characteristics, the environment of the job site. So that technology leap is very important. And we've seen several really exciting applications come up like open space, right? Passive sensing, machine vision on progress tracking in construction, recognizing objects automatically and recording, documenting, and creating progress analytics. The third factor is a generational shift in the adoption of technology, that people actually want to use technology now, because now when we go to work, we want to use some of the same interfaces and technologies that we're used to in our personal lives. We're demanding the user interface, the usability of technology in the workplace. And so in order to attract and retain young talent in construction, we actually must offer a better experience, a better technology-enabled workplace. And we touched on labor shortage, and what that's also done in the context of these technology tailwinds, it's opened the dialogue around robotic automation. There's historically been resistance to it, there still is some, but the labor shortage now is so critical that robotic system is having a window of opportunity to scale on the job site, and I'll show you a couple examples of that. And lastly, sustainability, right? We all know that the built environment accounts for over 40% of global greenhouse gas emissions, right? So that divides up roughly 8 or 9% in embodied carbon, which are the materials and the inputs to the buildings. About 4% or so plus is process carbon, which is the carbon footprint of construction process itself. And then the remainder of that, somewhere around 28 percentage points of the 40 percentage points total, is in the operating life cycle of the building. As the building operates in the coming decades, it generates a carbon footprint. So 40 percentage points of all global greenhouse gas emissions. So we know we can move the needle here, and now there are policy incentives, and then there are incentives from an investor perspective, right, to measure and improve and optimize. So here are a couple of trends that we see in areas where we think technology can help address construction innovation. So going from the top left-hand corner and clockwise, we touched on digitization of expertise and workflow. This means hardware and robotic systems, as well as software, machine vision, automation, AI systems, right? AI is getting a lot of attention these days with GPT-3 and GPT-4. We also look at people, materials, and equipment. So we're thinking very actively about what the supply chain of the future will look like in construction. What would happen if supply and demand can connect? There's real-time availability and inventory and pricing information. There's on average between 5 to 7 middlemen between the materials and when it gets to the job site. So I'm not saying that all of the intermediaries are unnecessary, but clearly there are some efficiencies that can enable better flow of information and transactions. So can we apply a marketplace model and a data model to the supply chain, right? We touched on sustainability. I want to jump to the left-hand side on financial services briefly. There's a cash flow problem that's plagued the construction industry, right? There's a huge delta between when the subcontractors has to pay for materials and labor and when the subcontractors gets paid from the GC. So in order to bridge that gap, there has been several companies that's been created in the last few years to apply a verticalized credit risk model. Now, I mentioned that there's now digitization of information and availability of information. Well, guess what? You can now build a credit risk model that's not just horizontal to any small business, but as specific to construction contractors and specialty subcontractors. And that information allows for a lending product, credit products, to emerge that's specifically tied to the performance and the credit risk of these types of businesses. So good businesses can get access to credit and short-term loans to address the cash flow gap in operating their business, right? We know a lot of these specialty trade partners, subcontractors, great at doing the work, but they may not necessarily be great always at management of cash flow and business operations. So these kinds of financial services solutions can unlock growth in the subcontractor ecosystem. And lastly, I'll also give you an example in a short while about building management and operations. Obviously, that's an area we think about actively for construction phase as well as during the building life cycle. In other words, can we install technology during the construction phase to make the building more efficient, more valuable during its operating phase, so that the technology can benefit both construction and the operating life cycle of the building. So what have we been doing at Suffolk Technologies? 3 kind of major areas. One is we've been validating, testing, and writing case studies about business models and technologies that work in construction. And that means adopting those solutions at Suffolk Construction across the Suffolk ecosystem, validating the ROI associated with these solutions, and then helping the rest of the industry understand the benefits. The second is we've been accelerating technology companies through a program called Boost. We created Boost in 2020. It's now known as the Y Combinator of construction. We felt that rather than a generalized accelerator model, that our industry is so complex and so fragmented and so multi-stakeholder in nature that we needed to bring the industry together and create a new type of accelerator program. So we brought real estate partners to the table, equipment, materials, subcontracting, technology partners, et cetera. And we have over 200 companies apply every year across the world. In fact, many companies are looking to bring their solutions from abroad to the US. And last year we selected 7 companies. We've been running this program for 3 cycles. Last year we picked 7 companies and we assembled a team around each company that composes of Suffolk project managers and experts, but also mentors, advisors, and other industry stakeholders that can add value, because sometimes the value proposition crosses over a number of different stakeholders. So if we can piece together insurance with a risk mitigation solution for construction, well, guess what? We just improved the ROI equation of that startup, right? So it required a different kind of approach to innovation. And the third part is investment capital. We've been investing actively in construction tech and real estate tech companies. We've made over 30 investments since 2019. And recently we were recognized by AGC as the most active construction tech venture capital firm. I'm going to show you a couple of examples of technologies to kind of illustrate some of these innovation themes. We're going to start in pre-con around surveying and analysis of images that are captured by satellites, aerial, and drones. How do we turn those images into models for permitting, design, and engineering? And do it rapidly. Take advantage of all the great information that's being captured by the pervasive sensors that I mentioned. Next, we're going to look at two robotics examples. How they enable factory in the field, right? We talked about manufacturing now over the past few decades have benefited from tremendous productivity gains. Can we replicate some of those dynamics on the job site? Can we make the job site smarter, more automated, and more productive? Then we're going to look at a supply chain materials procurement solution, and then we'll finish with a smart sensor technology that is both mitigating water loss damage and also improving the building health and sustainability in the operating life cycle. So let's start with a company called Airworks, which is in the pre-construction and surveying analysis space, okay? Automating analysis of images from drones, aerial, and satellites.
Take aerial mapping, for instance. Getting amazing 3D point cloud scans from UAV imagery has given surveyors a massive advantage when mapping out their job sites. Here's the problem: the massive amount of data that's collected, which can be extremely overbearing and time-consuming to segment and classify. What if there was a way to autonomously analyze all of that geospatial data, turning this into this automatically, letting you work on other things? Well, there is. It's called Airworks. Airworks is an aerial mapping software that helps land developers, civil engineers, and surveyors evaluate more job sites within their critical planning and acquisition schedules through proprietary machine learning and aerial mapping technology. Whew. To put it simply, Airworks can convert any aerial dataset into CAD site plans ridiculously fast, speeding up the current surveying process by weeks. So, how's it work? It's simple. Just upload your TIFF or LAS files directly to the Airworks platform. Define the site boundaries and let the magic happen. The Airworks software analyzes millions of data points from these files, autonomously classifying them into real-world features like topography, vegetation, roads, water, buildings, and literally everything else. This is a game changer, and all of this is done by the Airworks platform, allowing you to do other things. Join the hundreds of land developers and engineers already using Airworks to make faster, smarter, and more accurate site plans. Airworks, taking surveying to new heights.
Okay, so what's the technology trend here, right? There's been an explosion of built environment data that's become available from the pervasive sensors, cameras, images that are captured. And the rate at which that data is increasing is exponential. And so what do we need here? We need a technology, an AI-enabled solution to speed up the analysis of all of that data so then we can make use of it. We can extract the right kind of insights from it. We can't continue to do manual analysis against machine speed generated data. We need machine speed analysis to work with machine speed generated information, right? So that's the technology trend that's happening here. That's how AI is being applied in this case. And on average, Airworks is accelerating pre-con, in many cases up to 30%, right? So instead of manual labeling of those images that you've seen before, AI is now recognizing things like vegetation, roads, rooftops, manhole covers, sidewalks, etc., and tagging those attributes. It's a perfect use case for machine vision. The next solution I want to show you a robotics technology company called Rugged. This is a company that's based in Houston, founded by former NASA engineers. Their first product is tackling field layout, replacing kind of the slow, error-prone manual process with a fully autonomous vehicle. And this vehicle takes 2D and 3D model information, 2D CAD and 3D model information, and prints that directly, the architectural and engineering drawings, directly onto the unfinished floor. Okay, so let's take a look at what this looks like. You'll see it looks a little bit like a Roomba, right? This system, once it's configured against the control point, it has a fully autonomous, fully holonomic drive system on the wheels, so meaning the wheels can turn and drive this robot in any direction at any time. And it does a coordinated print of the layout across all of the trades all at once, accurately. And this technology was just recently used on a Suffolk construction job site in Times Square, okay? And what this does is it helps to reduce errors, identify potential clashes early on, and serves sort of as a single source of truth in layout. Okay? And part of why construction has been inefficient is rework. So having this solution early in the process can help reduce errors and rework in construction, right? And the next solution I want to show you is a company called Canvas Robotics. Again, keep in mind that these robots are being deployed in the field working alongside skilled trades to make the work faster and more accurate and more efficient, right? This solution is focused on drywall finishing, actually. This robot does a drywall finish, but it's controlled with the tablet, and it works alongside an operator to do drywall finishing much faster. So let's take a look at what it looks like. You can see this machine can elevate. It's built on a standard lift. None of the hardware here is necessarily all that proprietary. It's mostly off the shelf. You saw that it does a single compound spray. It started with the level 5 finish. Recently launched also a level 4 targeted spray that can spray over the joints. And it has onboard sensors to do continuous quality control and quality analysis. The articulation at the end of the robot can be switched out for a vacuum sander. You just saw it did vacuum sanding, so it keeps the job site clean. And there's telepresence and support, live support as well. So this technology accelerates drywall finishing from a 7-day process down to a 2-day process. We put this company through our Boost program. And during the Boost program, we took historical project schedules and simulated the robot's performance on those historical several $100 million projects, and we wanted to know how does it save on the schedule and on what projects that savings was real and impactful. We found that on several of the projects, in particular the ones where drywall was on the critical path, there were significant savings on the schedule on the back end. So with that information, we also helped this company raise capital from other VCs. I mean, remember, most VCs out there are not very familiar with construction. So we see our role being as well to unlock capital, more capital for these innovations that work, right? We invest, but we also enable other investors to learn and invest capital as well. So I want to maybe do a general point around these robotic companies, right? I would say that 5-7 years ago, this would have been much harder to do. Luckily, we've had autonomous driving. Tesla's done the hard work, right? A lot of the foundational technologies that you've seen here, they're just a transfer from another industry, autonomous driving, right? The sensor fusion, the navigation, the motion planning. The founders of this company came from Boston Dynamics, the big military robot dog company. So that's what's enabling construction today so quickly for these innovations to come up and get developed and tested. Next, I want to talk briefly about a company called Kojo, which has created a materials procurement platform for MEP subcontractors and now expanding to a number of other trades. This company is applying a well-known technology pattern. It looks like shopping on Amazon. Using this app, the field, the procurement office, the vendors, the warehouse all get onto a single platform. They've created a universal product catalog, taking all of the different SKUs of electrical, mechanical, plumbing materials, for example, across all the distributors and manufacturers, and then normalizing all of that into a visual product catalog. So you don't have to remember the SKU numbers anymore. It's shopping just like someone would shop on Amazon. The company recently launched an automated invoice matching solution because when you have the data, see, you can enable some interesting use cases. So this invoice matching product allows contractors to do a 3-way reconciliation to make sure that what they're paying for actually matches what arrived on the job site, right? That wasn't possible before when the information was fragmented across different systems, but it is possible now when all that information is on Kojo. So to date, they've now expanded to 8 of the largest trades, and they've powered, I think, close to about 10,000 projects with this solution, and help to eliminate a significant amount of materials waste on the job site, right? Sometimes from redundant ordering and not tracking properly. So finally, there's one system to help enable that. I think I'm almost out of time here. I just want to wrap up with a technology called WINT, which is downstream. We're moving upstream from pre-con to robotics to procurement now downstream. However, this solution is now being installed in construction as well. It's a water damage mitigation sensor technology. The solution works on top of existing off-the-shelf flow meters, as well as shutoff valves. And it measures water flow at a very high resolution and analyzes water flow. So you can see the signal processing pattern down below. It's monitoring, in this case, a toilet flush. So when the toilet flush is completed, the water tank fills up, and it should normalize down to 0, right, when the water tank is finished filling up, but it stays elevated, in this case, indicating there's a leaky toilet or a stuck toilet. So that's obviously a property management use case for the most part, but also for construction, right? So these sensors are installed distributed across the building. During construction, we know that builders' risk claims, there's water damage is a significant source of those builders' risk claims. And using this technology, we linked this company up with insurance during our Boost program as well. So this is an example of a solution that can make a difference in construction and in property management. And when it's installed during construction, the asset owner and the operator can just take over the subscription. Because guess what? The installation cost was already incurred during construction. Right? So the subscription can simply just transfer. And I'll just touch on sustainability very quickly. A leaky toilet, they did a study on the sustainability impact of water and found that some really interesting metrics, like a leaky toilet on average over a year generates the same carbon footprint as a passenger car over that same period of time. So obviously addressing water has a significant cost savings, but also a sustainability impact across both construction and real estate operations. So those are the 4 solutions I showed you. Airworks for pre-con, 2 robotic solutions that's creating factory in the field, a better way to procure and buy materials, connecting buy side and supply side in an Amazon-like model, and finally a smart sensor solution so that we can build smart and result in smart buildings, right? Building smart leads to smart buildings. And that's all I have. That's my email address. Love to connect and talk to you more about these companies if you're interested. Thank you.
Thank you so much. Sharing these amazing solutions with us. We really appreciate you.